is if you're looking at a formula, how do you tell which category it fits into? Okay? If the formula has a metal and a non-metal, if the formula has a metal and a non-metal, okay, now that might be more than one. I mean, we could have like 2 chlorines, but it's metal and non-metal. Okay? That's always, at least in this class, ionic. Okay? That's ionic. Sometimes it isn't, but for this class, I won't throw one at you that's going to be that confusing. Okay? All right. If there's a polyatomic ion in the formula, so nitrate is a polyatomic ion. There's a polyatomic ion in this formula then. That's ionic.
So it can be either one, it doesn't have to have both?
That's correct. The exception is, for both of these, anytime there's hydrogen in the front, okay, hydrogen is not a metal, although it's on the side of the periodic table where the metals are located. Remember, it's an exception. It's a non-metal. Okay? Whenever there's a hydrogen on the front of a polyatomic ion, that makes it an acid. When there's a hydrogen on the front of some other non-metal, typically you put two non-metals together, you get something that's covalent. But if it's hydrogen on the front, except for water, we're going to assume that to be an acid. Okay? At this point in time. Now we're actually going to change some of those rules in a later unit. Okay? We have a whole unit on acid-base theory. Okay? But for right now, if there's hydrogen on the front of the formula, okay, then we're going to assume that to be an acid for now. Okay? Alright. So then we get into the covalence. Covalents always combine non-metals. Okay? So anytime I've got non-metals, then I've got a covalent compound, at least for this class at this time. Okay? So we're going to use the covalent naming rules unless you got some carbons around. Alright? So, anytime you have a structure where carbons are bonded to other carbons, you're going to use the organic naming system. Anytime you have carbons bonded to other carbons, that's a covalent compound, but it's going to be organic, and you're going to use the organic naming system for that. So in both cases you use prefixes, but it's a lot more complex with organic. So this would be dinitrogen tetroxide. Okay? But organic might be something like this. Okay? Where carbons are bonded to other carbons. The only way this will work is if carbons are bonded to other carbons. So you have to use the organic naming rules for this. Now it gets a little bit confusing sometimes when there's only one carbon around. So there's only one carbon around in this formula, but it's not just non-metals, is it? Okay, so this is not going to be organic, even though there's a carbon there. Okay, this is actually a polyatomic ion right here. And there are a lot of polyatomic ions that contain carbon, so you have to be a little bit careful about that. Anytime you have carbons bonded to other carbons, that's organic, but occasionally you'll have some formulas where you only have one carbon. Like methane or methanol. Those are still organic. Okay? And because carbon is the center of the structure, I guess is the way to think about it. If you do the whole structural formula of these, the only way this works out is if carbon is the backbone of the structure. Okay? In both cases, carbon is the backbone of the structure, and that makes it organic. A little more complex with the single carbons. than others, okay? Now we can get into really complex things like DNA, which is organic, even though there's a lot of things in there besides carbons. There's nitrogens and oxygens and sulfurs and one thing and another, but the backbone for the structure is still basically carbon, okay? And that makes it an organic molecule. Really huge, but it's still an organic molecule. All right. In fact, you could argue that DNA is two molecules that are actually kind of affixed to each other through what's called hydrogen bonding. Okay. Any questions about organic or about naming now systems? So, I'm sorry. Go ahead.
So what's the non-metal with a polyatomic
A non-metal with a polyatomic ion? We're not going to be naming any of those in here. Okay. There are cases where you have organic compounds that sometimes have polyatomic ions attached to them in places. We're not going to do that in here. Okay? That's way beyond the scope of this class. Well, there's one little lab right at the end of class I would like to do if we have time. And you have to kind of understand a little bit about that. But that'll be after we do all the acids and stuff. Okay?